Welcome students. So in last class we have read about resistance, resistivity, dependence on resistivity and resistance, dependence on of resistance on length of conductor and area of cross section of conductor as well as temperature. So today we will read about combination of resistances. Combination of resistances. Combination means we will connect more than one resistance and will find the total resistance. That is the combination of resistance. There are two combinations. One combination is series combination and the second combination is parallel combination. One is series combination and second one is parallel combination. We will read both the combination today and we will find the formula, we will derive the formula for the total resistance of the combination. Okay. So first of all we will read about series combination. We can say series combination as end-to-end combination, means just see the figure. I will take three resistances. This is one resistance here, another resistance here, and another resistance here. And these three resistances will be connected to a switch and to a cell or battery, and the circuit is completed here. All the resistances here, number one is R1, this is R2, resistance 2, this is R3, resistance 3. Clear? This battery is giving voltage or potential difference V and current I. Now, why it is called series combination? Now see here, this is point A, this is the two end points of a resistance R1 AB. To the B point, second resistance is connected, this is the C and this is the D. See here, to B point, BC is the end of the resistance R2, and here R2 is connected to B, here R3 is connected to C. Now see here, how can we find or how can we know the combination is series? First of all, draw the direction of current here, from positive, from here to here, next to here, there, here, here. See here, current is starting from battery, going through this resistor R1, next to R2, next to R3, then coming to the negative terminal of the battery. This is the positive terminal, this is the negative terminal. Now see here, while current is traveling through three resistances, current is having only single path, a single path. That means current flows in a single path in case of series combination. Clear? When current flows in a single path, we can say that the resistances are connected in series. Is it clear? Now, in series combination, what are the characteristics of series combination? We can say current flows in a single path. First characteristic. The second characteristics, current remains constant and voltage varies according to resistance. That means according to the value of resistances, the voltage varies but current remains constant. That means how much current is flowing from the battery, that much current is traveling or flowing through each of the resistances. Now, if the voltage changes according to the value of resistance, suppose this here the voltage is V1, here the voltage is V2, here the voltage is V3, the total current is I here always same in across all the resistances. Battery is providing the voltage V. This voltage V is the sum of these three voltages V1 and V2 and V3. So we can write, I will erase this. So we can write, we will have what? V is equal to V1 plus a V2 plus a V3. V equal to V1 plus V2 plus V3. Now, we know Ohm's law, V is directly proportional to I, or V is equal to Ri. Or we can write IR because Ohm's law. This is V1, current is I, resistance is R1, so I can write V1 is equal to IR1 plus here IR2 plus here IR3. So V, instead of a V I have written IR, instead of a V1 I have written IR1, instead of a V2 I have written IR2, instead of a V3 I have written IR3. Now take common. So we'll have R is equal to, or IR is equal to, I take common R1 plus R2 plus R3. Or if both side I will be cancelled, we can write R is equal to R1 plus R2 plus R3. This is the formula. R equal to R1 plus R2 plus R3. Now what is R? This R is called equivalent resistance, or I can write total resistance, or I can write effective resistance. Equivalent resistance, total resistance, or effective resistance. Now see here, total resistance will be sum of individual resistances. R equal to R1 plus R2 plus R3. Now suppose there are three resistances connected in series. R1 equal to 2 ohm, R2 equal to 3 ohm, R3 equal to 1 ohm. All three are connected in series. So here R equal to R1 plus R2 plus R3, total resistance. So it will be 2 plus 3 plus 1, which will be 6 ohm. Now see here, in case of series combination, we have got the total resistance 6 ohm. It means in series combination, the total resistance increases. Clear? The total resistance increases in case of series combination. Is it clear? Now, the reverse thing happens in parallel combination. Let us read about parallel combination. See how I am drawing the circuit here. This is one, this is one, this is one. 3 resistances, all 3 are connected, all the ends are connected here. This is the key. This is R1, this is R2, R3. The battery is providing voltage V and current I. Now, in case of a parallel combination, what happens? Remember, the reverse thing happens in parallel combination. What? Current flows in more than one path. Current flows in more than one path. In series combination, current was flowing in a single path, but in parallel combination, the current flows in more than one path. Next, what? In series combination, voltage changes, or voltage varies according to the resistances, but here voltage remains constant. But current varies according to resistance. So here voltage is constant, V. Current varies, that means here current is I1, here current is I2, here current is I3. So question will come, why current varies? Let us take an example. Take a water pipe and make different holes in the water pipe. Through the holes, water will come out. But you will see that in different hole, the water pressure is different. Is it clear? The water pressure is different, but total amount of water remains constant. If the total amount of water will be the total current provided by the battery, and the amount of water is taken as the amount of water in each hole is taken as the current across each resistor, we can say that according to the hole, according to the size of hole, the amount of water will come out. That means the total water will be equal to the amount of water flowing through different holes. So in parallel combination, we can write what we can write? I equal to I1 plus I2 plus I3. I equal to I1 plus I2 plus I3. Now, we know in case of Ohm's law, V is equal to IR or I equal to V by R, put here. So we can write V by R equal to here V by R1 plus V by R2 plus V by R3, or I can write 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula for parallel combination. Now see here, in series combination there was equivalent resistance was R equal to R1 plus R2 plus R3, but here there is the reciprocal of the resistances. Okay, what we'll do, we'll take two resistances. We will take two resistances, number 1 here and number 2 here, all are connected in parallel. This is R1, this is R2. We know 1 by R equal to 1 by R1 plus 1 by R2. Take the LCM, so it will be R1 R2, it will be R1 plus R2, or I can write R equal to R1 R2 by R1 plus R2. So you can write here, say here the equivalent resistance we can find as the sum of reciprocal of individual resistances. But remember, always whenever you want to solve a numerical problem on the combination of resistance, always find R, not 1 by R. It may be series, may be parallel. So suppose this is 2 ohm, this is 2 ohm. So our parallel combination formula will be 1 by R1 plus 1 by R2. It will be 1 by 2 plus 1 by 2. LCM is 4, or we can write LCM is 2. 1 plus 1, it will be 1, or R equal to 1 ohm. So here you see, initially each resistance was 2 ohm. Here total resistance will become 1 ohm. It means that in case of a parallel combination, the total resistance decreases. And how decreases? Remember always, the total resistance is always less than individual resistances. 1 is less than 2, this one is less than 2. If the total resistance or equivalent resistance is always less than individual resistances, then you can say that your numerical problem is correct. Clear? So you will solve the numerical problems from your book, and whatever will be the doubt, you will message me. In the next class, we will read the next part of the chapter. Thank you everybody.